This is for General Maths Specialist. It's an overview of statics. If we had an object sitting on a horizontal table and it's at rest, then what are all the forces that are acting on that? We have a weight force due to gravity. Because of Newton's law, we will have a normal force which will be opposite that. If there's a pulling force that's pulling towards the right and it's not moving, then there will be some sort of frictional force which will balance that pulling force, and that because it's at rest, R equals 0, the resultant force equals 0, therefore P will equal F and N will equal W. Remembering that forces are always equal to mass times acceleration. Therefore, W will be the mass times acceleration, which in this case is gravity, which is the gravitational force. Okay, let's say acceleration did occur, and that acceleration was in the form of 1 meters per second squared to the right, and the mass is going to be 10 kilograms. I'm going to have some sort of weight force, which will be 10 times 10, or 100 newtons. And we're going to have a normal force, which will also equal 100 newtons, because N will equal W in this case. We'll have some sort of pulling force, and we'll have some sort of friction force. But in this case, the resultant force is not equal to 0, it's equal to mass times acceleration, which will be 10 times 1. So the resultant force is 10 newtons. And the resultant force will equal any forces in the direction of motion minus any forces in the opposite direction of motion. So 10 equals P minus F, therefore P equals F plus 10. Okay, now let's assume we have a 20 kilogram object sitting on an inclined plane at 45 degrees and it is at rest. And it's just sitting there. There's no force holding it where it is. Okay, what are the forces we have? We have W, which is our weight force, which in this case happens to equal 20 by 10 or 200 newtons. We will have some sort of friction force, and that friction force will be in the opposite direction of motion, and it's up the plane because the object would want to slide down the plane. And we'll have some sort of normal force. Now I can break my weight force into two forces, one which is perpendicular to the plane and one which is parallel to the plane. If that's 45 degrees, that's going to be 45 degrees. Now obviously my picture isn't to scale. So this is going to be W times the cosine of 45 degrees, and 45 degrees is pi on 4, it's going to be root 2 on 2. This is going to be W sine of 45, which is going to be 200 times root 2 on 2, or 100 root 2, and this is also going to be 100 root 2. So, what are all the forces that we have? It is at rest, therefore my resultant force equals 0. Therefore all forces will be balanced. The friction force has to equal this one here, 100 root 2 newtons. The normal force has to equal this one, which is also 100 root 2 newtons. Okay, let's say we have a car pulling a boat out of the water and it's inclined at 45 degrees. We know that the car and the boat are 1,000 kilograms, that there's some frictional force of 100 newtons. We have acceleration up the ramp at 2 meters per second squared, and the question is find the pulling force. Okay, I'm going to redraw it so that I don't have a car and a boat, but I have an object which represents the car and the boat. It has a weight force. It's 1,000 kilograms times 10 to give 10,000 newtons. There's a pulling force by the engine of the car. There's normal, and there's friction. Now notice the friction has now flipped around. In the previous question, because the block was going to fall down the incline, friction was up the incline. In this case, acceleration is up the incline, so friction will be opposite. Okay, so we're going to try and find the pulling force. Okay, so here is our boat and car. There is a weight force, which will be the weight of the boat and the car, which will be 1,000 times 10, or 10,000 newtons. There's a pulling force, and the question's asking us for the pulling force. There's a frictional force of 100 newtons. I can break my weight force into two forces. Obviously, this isn't to scale. This will be 10,000 times the cosine of 45, which is 10,000 by root 2 on 2, which is 5,000 root 2 newtons. And this will be 10,000 times the sine of 45 degrees, which also equals 5,000 root 2 newtons. Okay, so what have we got? We know that there's an acceleration of 2 meters per second squared. Therefore, my resultant force is going to equal mass times acceleration. The mass is 1,000 by 2, which is 2,000 newtons. That is my resultant force. The resultant force will equal all forces in the direction of motion, which is P, minus all forces which are opposite to motion, which will be 100 from friction and 5,000 root 2. Which means P is going to equal my resultant force, which is 2,000 minus plus 100 plus 5,000 root 2. Therefore, P, the pulling force, will be 2,100 plus 5,000 root 2 newtons.